So hi guys, in this video lesson, we are going to study the IUPAC nomenclatures of our alkanes and cycloalkanes. So here I'm going to be giving you basic rules, and as usual, you know what you're supposed to do. You keep everything simple. You have to hold your notebook, and as well, make sure you write down everything that I've tried to break down with the PowerPoint slide here. So the essence of doing this is to make it very simple and to make the visualization so real in such a way that I'll be easy, or it will be easy for me to take you guys through it. So let's start with the class. So about the first point about today, we are talking about IUPAC, which we have studied before, which means the International Union of Pure and Applied Chemistry. Now, having said that, in this video lessons, we are going to discuss about the branched chain alkanes and their rules, corresponding rules we use in naming them. So let's start. The first step, which is the step one, we're going to talk about is I always tell students about this in classroom. You are to choose the longest continuous chain of carbon atoms. This chain determines the parent name for alkanes. Yeah, you need to understand something. We call this a carbon-carbon chain. So please always keep that at the back of your mind. The carbon-carbon chain is very, very important. Carbon-carbon chain. So the longest carbon-carbon chain should be what? So it is not necessary that this longest carbon-carbon chain should be a straight chain. So always keep that at the back of your mind. Now, looking at this, guys, the longest carbon-carbon chain here in this case is like a straight chain. What you guys are used to, 1, 2, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So I will show you so that you guys are going to see it well. Now, the parent's name is Xn because the longest carbon chain is 6, which we have discussed, which makes that very simple. In this case now, if you watch, if we count the longest carbon chain on a straight chain, we are going to see we have 1, 2, 3, 4, 5, and 6. But if we start from the down part, we have 1, 2, 3, 4, 5, 6, 7. So always focus on the carbon-carbon chain and always focus on the longest carbon-carbon chain, which is not necessarily going to be the straight chain. So keep that in mind. Let's count this together. If you can see this, we have the parent's name is F10, and how do you come about that? It is by what I just told you, by counting from here 2, 3, 4, 5, 6, and 7. And we take the rest as well, the substitution, which actually wants. So the next one, here is the step two. About the step two, always keep it in mind that the number of the longest chain beginning with the end of the chain nearer to the substituent. So this is always basic because I believe you have also learned this, because if you want to go for the longest chain, so you have to make sure the one that is close to us, where you start counting, should be very, very close to your substituent. We have also talked about substituents in our previous lesson. So what we're talking about here is what we can show an example. A very good example is this. As you can see, if I start counting from the front, this is going to give me 1, 2, 3, 4, and 5 on the substituent. If I start counting here, I have 1, 2, 3, 4, 5, and 6. So it should be on the second. So we always consider the one that is close to the carbon chain, that is close to the substituent of the carbon chain. So keep that in mind. It's very, very important in naming of what our organic compound. So as you can see, the substituent is CH3, which is called methyl. I'm going to list out all the substituents you need to keep in mind for easier naming, for you not to have difficulties when you are naming organic compound. So about this, the first one, you can see 1, I'm doing that 2, and we have the 3, we have the 4, we have the 5, we have the 6. You can see I have to start naming from the back the carbon chain, because if I start from the front, the substituent will be 5. Then the number of carbon that should be equivalent to the substituent will be like 4, or the fifth carbon, which is not acceptable in any organic compound. So keep that in mind as a step 2. Then we'll move to the next step. So about the next step, Or before we go into the next step, let's take one more example in this case. You can see this, when we name this is this, very good. Now, the longest carbon chain, like I said, is not necessarily going to be the what? The straight chain. So here, counting this one, as usual, we have the substituents. That is the substituents here. Then we've done this in example one before. Then we start naming from what the down part here, which is we have 1, 2, 3. As you can see, on the third carbon, we have the substituent CH3, which is methyl. So then we continue in sequence 4, 5, 6, and 7. So guys, this is the methodology we use in naming organic compound. Focus on the substituent, start naming from a site that is close to the substituent. So, and this is how we do that. So guys, the next one is step 3. About step 3, I do tell you this is very important, what we call use the second rule to locate the position of the substituent. As we've discussed, make sure that what the counting of your carbon chain is very close to the substituent. Then, having done that, the position and the name of the substituent must be written in front of the parent chain. So that means there is another rule that says you must be careful about how you write the organic compound. You have to be very, very careful. Now, the position and the name of the substituent must be written in front. That means you write it before the parent's name. And there's also a methodology you follow in terms of the comma and the hyphen, which we are still going to talk about. Now, example about this is this. Now, we've located the substituent, which is CH3. So we start naming from which is close to it. That is from the back. We have the 1, we have the 2, 3, 4, 5, and 6. So now we want to name. If we name this, now it's very simple. The substituent here, as you can see, is as the second carbon, and the substituent is called methyl. CH3 is called methyl. So, and what that means, my dear student, is that what the name of this is what the parent's name is hexane because of 6 carbon atom. That is hexane. And because it is hexane, we are going to put the name of the position of the substituent. Look at it, 2. Then I have the dash, which is hyphen. Then methyl, the name of the substituent. Then the parent's name, which is what hexane. So this is the way we do that. You need to be careful about that, especially for beginners. And we start from what the basics before we go to the advanced. The next one, or we take one more example from the standing sake. Focus on the substituents. The substituent here is CH3. You can see that. Good. Fine. Now the next point is what we start naming. 1, 2, then 3. On the third carbon, we have the substituents. So that means it will be 3-methyl. Then the parent's name, you can see, which is what we've talked about, the 6th and the 7th carbon atom. So this is 3-methyl. Can you see substituent methyl is at the third carbon? So this is 3-methyl heptane. Be careful about the naming. It's very important you understand how to write 3-methyl together every time. So the next, we talk about some common substituents. And why I want you guys to keep this in mind is because I am going to be using this in the later part of the slide when I'm doing examples. So these are some common substituents and how you can always keep them at the back of your mind. So directly when we are naming, it should not be difficult. The first one is, you see, metal. Metal is given as CH3. You need to be careful about that. So, and it is belonging to the family of what we call an alkyl or alkyl group. So they have general formula. Ethyl is a CH2CH3. You can see the meaning of this means what it is what going to be attached. It's a substituent. So you keep it in mind, CH3. In fact, general rule for alkyls, the general formula is CnH2n plus 1. I'm not going to rush you because we are still going to talk about this when we talk about the property of what called alkanes and alkanes. You are going to understand better all these stuff. Now, but for now, you keep all these substituent notes in mind. CH3 is called methyl or methyl, anyhow you are used to calling that. So ethyl, which is a substituent from alkane, you can see we only remove 1 hydrogen from heat. That is how to understand better. You can see ethane is a CH3, so now CH2CH3 will give you ethyl. So that is the way we move. Then the next one is from what? Propyl. So which is the same thing. We remove one hydrogen, you can see this is CH2, CH2, CH3. Methyl, CH3, ethyl, CH2, CH3. Propyl, CH2, CH2, CH3. Three carbon atom, but it is shortening what? One of your hydrogen. So that is the methodology. Be careful about that. Then the next one we can also talk about is very important, which we call isopropyl or isopropyl. Now, about isopropyl. Now, most of these are actually carved out from the isomers we've talked about, the chain isomer we talked about in the previous lesson. Now, isopropyl, you can keep it at the back of your mind. You can see it's very simple to know. Now, I told you when you have the methyl, for example, when you have the methyl that is attached to the what? To the first carbon, to the first carbon. That we call iso. So in this case, look at the first carbon is C. Then we have the CH3. Then the other metal is at the other side. So the combination of our CH3, HCH3 is called isopropyl. If you can't, you can say one. You can say 1, 2, and 3. You can say this is 1, 2, 3. So another person can write it like C3, H, you can say 3 plus 3, 6, 7. And say C3H7, but the arrangement matters. The methyl is like this. Sorry, this is 1 carbon, 2 carbon, and this is the third carbon from anti-carbon. So, but the methyl is at the first carbon atom, and you can say at the first and the second carbon. So we call it what? Isopropyl. So keep that in mind. This is also very important. I always tell students this substituent is one of the most important substituents which we are still going to talk. I told you when I was taking the isomerism, the basics of the isomerism in the previous slide about the alkane family. We talked about the iso and the what and the normal. I told you the normal, which is the first isomer, the iso and the what and the neo, which is the one that has double methyl group. So don't worry, you are still going to get all this, like I said, but for now, you keep them in mind as substituents. And isopropyl is CHCH3, then CH3. CHCH3, then the first CH3 is under the first carbon atom, and the second one is placed directly after the CH. It is very simple to keep it at the back. So the next one we talked about, which is carved out from what? Butane, which is butyl. We've talked about propyl from propane. So we understand to start from CH2, CH2, CH2. Then the last one is CH3. 1, 2, 3, 4. The general formula of our K group is CnH2n plus 1. This is very easy to do. Why we talk about this is for you to understand, because we want to talk about what isobutyl now. In this case, we talk about propyl. You can say propyl is CH2, CH2, CH3. In this case, for you to understand isopropyl very well again, visualize CH3 here remains the same. The H in this particular one has now been transferred to the first one. You understand? This H has been transferred here, then it comes down here, then we say this is what we call isopropyl. Now, in case of isobutyl, you are going to see something synonymous. Now, watch. I will just be able to, I will be very quick to explain to you. Now, this is iso in this case. Now, in the previous one, I will show you, focus very well. You can see the CH3 here, which is the fourth carbon there. Here remains the CH3. But in this case, when we call it isobutyl, something will change. Now, the transfer we talked about, then we have CH2, we have CH2, we have CH2. Yeah, watch carefully. CH3 remains, then here at the second, the same thing again. The H here has now been transferred to come and mix this to convert to become CH3. So in that case, this is now called isobutyl. Isobutyl. So be careful about this. The arrangement is the same. Instead of CH2, 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 CH3, we have now turned into what? CH3, CH, then CH3. So the H that was transferred is now what was given to the third CH2 to make the CH. And again, this is at the second, the material is at the second carbon, as you can see, 1, 2. So this is called isobutyl. So be careful about these two. Isopropyl and isobutyl. It's very important for students to understand. So how do you remember? Write the normal propyl, then just try to transfer the carbon atom, the hydrogen atom in the second to the first one. When you do that, then it will return this one to methyl. You know what you write. In this case, write this, transfer this one to this, then it will be as a substituent to the first one. Then you have it. So guys, it's just more like memorizing because it's so easy. CH, you can see the H here as well. So the number one becomes CH3 and you have CH2. So please note that. Now, there is another thing we call secondary butyl, which is also a substituent. Don't forget we are talking about substituent. Now, what is the difference between an isobutyl and a secondary butyl? It is not too difficult. Secondary butyl. Now, the meaning of secondary butyl, you can see the major difference is just the position of the methyl group. Please focus. CH3 remains here. Now, in this case, now the CH3 is here. You can say CH3 here, whereby the CH2 is now being transferred to. So the name we give to this, be careful about isobutyl and secondary butyl. Now, in secondary butyl, what we try to do is that what the methyl group is what at the first, because why we call it secondary butyl is this. Now, the methyl group, now you can see this is attached to the what you can see here, the first, depending on where you are starting, either here or here, you can see at the beginning and the ending. So it is called secondary, which is what I expect you to ask me. When I did isopropyl, I said you make sure the methyl group is starting from the first carbon atom. Then when I want to do iso, I'm putting it at the second carbon atom. Now you should have asked me that why am I not putting it on the first carbon atom? And the reason is just because if it is on the first carbon atom, it has another name. In case of butyl, no, butyl now starts having different structure, different position at which you can put the methyl. You can put it at the first, the second. So when it's at the first, it's called the secondary butyl. And secondary is because of the two words alkyl group that are attached to it. That is where the use coming from. So a little bit of memorizing isopropyl, isobutyl, secondary propyl. Isopropyl is so easy because there are three carbons. On the first one, we attach the CH3. When you know how to write propyl, iso will be simple. The same thing to butyl. When you know how to write butyl, the next two words will be simple. Now, there's another one we need to talk about. That's the pentane and the new pentane, which I've talked about also in the isomer. So let's talk about that. Now, tertiary, very good. Tertiary butyl, it's so simple. Meaning of tertiary means you have three carbon or three alkyl group or alkyl group. The way you call it, you can say everything is now being gone together. So that's the meaning of what secondary and tertiary. In fact, you can also have quaternary, but quaternary is not possible in this case because there are only 4 carbon atoms. So guys, secondary and tertiary butyl, it's very easy to know. The only logic here is just to know that the only thing we are putting out is the carbon and the last CH3. Every other one has been given out. So this one has given out it's what you can see. It's very simple to draw. What I know that I want to draw is just from this isobutyl, the normal butyl CH3 remains the same. The hydrogen in this particular one has been moved to the hydrogen here, then up and down we have it. So I think this is even the simplest one to draw. CH3, only C standing at the middle, CH3 by the side, CH3 up, CH3 down. So these are substituents. You can see them directly attached to the main chain of an organic compound. So, and that is why you have to memorize them. If you know how to do that, you can do that by putting down a note. It's very simple, and I will move to the next one. The next one is neopentyl. I talked about that. Neopentyl. Now, when we have neopentyl, it is always carved out from what we call the dimethyl. When you have dimethyl on the same carbon atom, you have what dimethane. So whenever something is di and they are what on the same carbon, we call it what di. I will call it neo. Iso is you are talking about what methyl. But when you have two particular methyl on the same carbon atom, it's now called neo. So these are just names that we call all these stuff. They are nothing to be worried about. So be careful about it. It's so simple. Everybody knows pentane is 5 carbon. You can count. So easy to count. 1, 2, 3, 1, 2, 3, 4, and 5. So what we call it neo is that on this, you can see on this one, we have the methyl and we have methyl on the same carbon atom. So when you have methyl on the same carbon, we call it neo. When you have it on when the methyl is just one methyl on the carbon atom as a substituent is called iso. So iso in propyl is just one, but in butyl there are different arrangements. you can have the secondary and you can have the tertiary. So note that it's so simple to understand. And arranging this is so simple. You can say 1, 2, 3. And the remaining one is CH2. CH. To understand this, you can first of all write what the pentyl. So if you understand that pentyl, then write CH3, CH3, CH3 by the side. The center carbon atom will carry 2 CH3 and the third CH3 will be by the sides, as you can see. So then this, the remaining CH2, will stand by this side. So it's so easy when you know how to write the alkyl group. And practice do make perfect. All these I've listed here are what you are going to see in examples. And if you have mastered these substituents and you see them or visualize them as substituents, it will be kind of very easy for you to get them. So now the next thing I think we need to do here is to focus on what? On the cycle substituent. Cycle. Now, about the cycle substituent, be careful about this one. This is cyclopropyl. As you can see, if you see, this is carbon, carbon, carbon. This is 3 carbon. And you can see it's in the form of triangle. If it is attached directly to what? A particular what? Family or a particular what? Name. So it is called cyclopropyl. Cyclo because it is the main form, which we've talked about the general formula CnH2n starting from 3 and above. Now the next is cyclobutyl. I don't need to waste time. You can say 1, 2, 3, and what? And 4. So the next one, I just ask you to keep all this in what? In your mind. This is called phenyl. You can say C6H5. This is phenyl. Please note that sometimes it is written like this, sometimes it is drawn like this. So if it is attached to a particular family member, it is called what? A substituent. And when you see it like this, it is called phenyl. Sometimes you see C6H5. Keep this in mind. It is also popular for us to keep at the back of the mind. Next is yeah, very good. Now we call this benzyl, not benzene. Now when you have the phenyl that is also attached to what? CH2, it is called benzyl. So benzyl is phenyl and CH2. That is the logic. So please, we have to keep them in mind. I think all these cycles are simple to know. You know, when this is a substituent, 3 is cyclopropyl, 4 is cyclobutyl. When you have a structure of C6H5, incomplete structure of what as a substituent of your benzene, it is called phenyl. So which is also this. When it is attached to what CH2 also as a substituent, phenyl and CH2, it is called benzyl and not benzene. So these are substituents. So visualize them as substituents. You need to visualize them as substituents and not as something that is standing, you know. They are not they are not in the long chain. They are attached beside the long chain. So that is why we call them substituents. So in these lessons, we've learned about examples of what different substituents. We started from what the alkyl group, talked about the methyl, the propyl, the isopropyl. You understand? When we talk about the isopropyl, we talk about the isobutyl. We say that one can form isomers as a substituent. Talk about secondary and the tertiary, which also explained. We also talked about the neo, which I said is when you have 2 dimethyl attached to the same side. So we are still on naming. And we need to understand these substituents. I hope you have written them down. And if you have done that, the next is to continue with the laws of the lowest locant and how to also name what this what we call a cyclosubstance. So let's finish up with the law before we go to the cyclosubstance. So in continuation, you can see other substituents which are also very important are bromo is Br, chloro is what? Cl, fluoro is F, iodo is what? I. All these are your halogens you study in your physical chemistry, which I believe. Then hydroxys OH, amino, please keep it in mind, is NH2. Cyanide. Cyanide is called CN. Sometimes we also call it nitrite. Don't worry, I'll talk more about that when we get to that aspect. Like I said, I'm taking you slowly, gradually from 0 to hero. So it is just like a nitro. Please be careful. Nitro is NO2. Nitro is different from nitro. So all these I'm still going to talk about. So we move. The next is now this next point. That's the next law about the name. The next law is talking about let's visualize the next law. Fine. Now, if 2 or more substituents are present, now you have to give each substituent a number corresponding to its location on the longest chain. So now a good example for us to understand what I'm saying, the substituent should be labeled alphabetically. You have to label it alphabetically, and when you label alphabetically, you have to understand this. Now, in alphabetically naming, the prefix like di, like tri, like tetra, like secondary butyl, like tertiary butyl is always what? Ignored. I do tell students not to make this mistake because from my experience of teaching, this is where students make mistake. Now, you will ignore di, tri, tetra, secondary, and tertiary when you are what? Labeling alphabetically. So you know alphabetical order. So when you have more than two substituents present in a given compound. So be careful about this and don't make that. But there is an exception. When you have iso, when you have neo, we put them there. Whenever we have iso and neo, we put them there. But whenever we are labeling anything that is not iso and neo, it is always neglected. So let's move in sequence. And when we have that, we have a very good example, which I love. We have more than one substituent, which you can visualize. This is a substituent, and this is just let me ring them for you to see them well. Now, you can label the longest carbon chain is a straight chain, which is 6. Parent's name is hexane. Everybody knows this is the parent's name, hexane. Fine. Now, let's focus. Now, here we have methyl, and here we have CH3CH2, which we have talked about, which is called, and here, everything here is a substituent to is called ethyl, which you have done in the listing. I ask you to write them out. Then if you watch now, when we want to label, we label alphabetically. And I've told you, the parent's name comes last. The substituent comes in front of the parent's name. So if the substituents are coming in front of the parent's name, it is quite easy to understand that what you have to label alphabetically as what? E comes before what? Before him. So because E comes before him, that is what I am labeling as 4 hyphen ethyl, then hyphen again 2. You know, it is always the number hyphen the name of the substituent, the number hyphen the parent's name. So follow this way. Then another thing should have been, okay, fine. Why can't I start by 1, 2, 3, 4, 5, 6? Then I say 1, 2, 3, and I said I also have 5. The reason we are still going to talk about that is the reason we call lowest locant or lowest sum rule. So which we are still going to discuss. So for now, keep it in mind. I'm starting from the front, all because I want to label alphabetically, and again because if I start from the back, the addition I'm going to have will be greater than what? 4 plus 2 is 6. Like 4 plus 2 is 6. I'm talking about the position of the substitute. So if I start from here, 1, 2, 3, 4, 5. 3 plus 5 will be 8. In details, we are still going to discuss about it, so we don't need to rush ourselves. Now, the next should be step 5, which is law 5. About the law 5 says if two substituents are present on the same carbon atom, then you are going to write what? The name twice. It's very simple. If I have a substituent on the same carbon atom, that's number 3, I will not just write 2, but I'll write 2, 3, 3. You understand? Then I will name, follow the usual procedure. So we can take a very good example. Very good. Now we have a very good substituent. The parent's name should be noted first. The parent's name is very simple to note. And as you can see, the longest carbon chain we start 1, 2, 3, 4, 5, 6. If we start 1, 2, 3, you can say 3, 4, 5, 6. You just need to be careful about understanding how to count. Now, this is it. 3 ethyl, 3 methyl hexane. Now, 3 ethyl, 3 methyl hexane. Now, that's hexane. Now, the longest carbon chain is we have 6 carbon atoms, which you can see. Then on each of these are the substituents we are talking about. Look at the substituents. For understanding's sake, this is the first substituent. This is the second substituent. This is called methyl, and this is called ethyl. You have to label alphabetically to know that. Then again, the longest carbon chain is 1, 2, 3, 4. You can see 1, 2. That's why I'm showing you 3, 4, 5, 6. That's the longest carbon chain. Please when you spot the branching, so you can label now 3-ethyl, 3-methyl-hexane. So I have to write 3 twice. It doesn't stop anything, as you can see. So you need to be careful about all these things. So focus on the substituent to let you know the longest carbon chain. It is not necessarily going to be a straight chain. That is one thing. And if I can't the other way, which you know, it will give me a very wrong answer. So the next step, step 6. Now we have if 2 or more identical substituents, this is what we're talking about at present, use the prefix di for 2 identical substituents and tri for 3 identical substituents and tetra for more or 4. So please note that, which is your knowledge of mathematics, I think. So commas are used to separate numbers from each other. You know, when we want to separate numbers from each other, we use comma. But when you are writing substituents by each other by the side, which are not numbers or numeric, you are going to use what? The hyphen. 2-methyl, 2-methyl-butane. It is going to be 2 hyphen. But if it is 2, 2 dimethyl, so there will be comma between numbers. So you have to keep this in mind. Let's see some illustration to that. A good one. The good illustration I'll show you is this. Look at this. Very good. Now let's label this. The parent's name is very easy to know. We have spotted 2 substituents, which are what down here. Now this is 2, 3. Then the parent's name is 1, 2, 3, 4. You guys know this by now. 2, 3, and 4. So 1, 2, 3, 4. On the second and on the third, we have the substituents, which are methyl H. So 2, the numbers are separated by comma. The parent's name always comes last. Then hyphen for the what? The 2-methyl, which we call what? Dimethyl. When they are 3, we talk about tri. 4, we call them tetra. So we are moving and we are very close. The step 7, which is law 7, which I will give, is the one that shows or that talks about identical. Now let's check. If there are 2 chains of equal length as the parent chain, choose the chain with the greater number of substituents. Yes, this is very important in terms of substituents. In terms of substituents, we go for the greater number. But when it is not in terms of substituent, we don't go for the greater number. Students do make mistakes there. Now look at this. I'm going to let you know to understand this. Very good. I love this. Now we have different substituents, which you need to understand. Now, substituent spotted, substituent spotted, substituent spotted. Now, in fact, I can also take one particular this thing here, this particular thing from this point to this point as also a substituent. If you watch 1, 2, 3. On the first one, I have the methyl group. We've talked about iso. So you don't need to waste time. Let me show you for you to visualize. Look at the first way. The longest carbon chain is a straight chain. I start from the back because I spotted this. Now, then we have the first substituent, methyl. I'm trying to bring it out for you guys to see. The second one, that's also there. Then we have this one, which is very simple for you to know. You can see 1, 2, 3. You know that is what propyl. Then the fourth one, which you can also spot. The fourth one, which is also methyl. So you can label this like that, which is what you call, you can see 2 on the second carbon, I have the methyl. On the third carbon, separate numbers with comma, I have the methyl. On the fifth carbon, I have the methyl. So I have 3 methyl, we call it trimethyl. And hyphen, you have 4. This is another substituent, which is a propyl. Then 13. Now, this is correct. Very correct. Now, and again, there are how many substituents? 1, 2, 3, 4. I will go for the one that has the highest number of substituents. Now, if I have gone for this in this way, because this is a substituent on its own, this one and this side here is a substituent. I will have the 3 substituents. I want you to visualize this. Watch. Now, another way you might have named this is this. Now, watch this, guys. Now, we have another way now. Look at this now. I'm counting now. 1, 2, 3, 4. You can see that. Then I have my 5, 6, 7. I am taking these substituents. And if I go for that, this is the name I'm going to have. Please, you have to be careful and understand all these things. They are very simple. That's my first substituent. Can you see? That is my second substituent. And that is my third substituent. That was what I was showing you. You can see. Now, that is another way I can name, because I know that particular thing I have bring now is also a substituent, which I have given you on the substituent of iso. Now here in this case, this is very, very easy. Now you can see in this case now, I can name this one also like this. You can see 4 secondary butyl. I told you before, this particular substituent here, if I have counted like that, the second way of naming, you can see is what? 1, 2, 3, 4. This is secondary butyl. Why? Because methyl is at the first carbon atom. I told you before, secondary. If I put this one here and this one on the other side, it should be isobutyl. Now, secondary butyl, fine. Then, in this case, now, if I have taken this one as my substituent, I'm going to have just 3 substituents because I have counted this 1, 2, and this third one as my substituent. Then others, and that's my what? They are my what? My longest carbon chain. So the longest carbon chain is still 7. So I have 4 secondary. This is called at the fourth carbon atom. I have the secondary at the fourth carbon atom. I have the secondary butyl. You can say 4 secondary butyl. Then on the second and the third, I have the methyl. That is true. Separate number by comma, di, and I think dimethyl heptane. So, but this is the first one is more acceptable because they are 4 substituents than the second one. So be careful about this when you are naming. So keep that in mind when you are doing the naming of what you can name. So guys, I hope you are getting this, and that will now take us to the next point. We just need to be very careful when doing the name. Both are correct actually, but in examination we focus on on the first one, because the first one is more correct than the second one. So that is it. And that's why you can see question. I'm trying to ask you which one do you think is correct. Now, without any points in words, the first one is correct. Now, the second one. Now, the next, which is point 8, is if branching occur at an equal distance from either ends of the longest chain, choose the name that gives the lower number as the first point of difference. Now, this is always what I always call my love point of difference. I've done this a lot in some other videos, like I call it first point of difference. Now, the first point of difference is another law that will help you to know which one are you going for. Now, let's take a very good example for you to get. Look at this now. We have spotted 3 substituents, which is a straight substituent. You guys can see. Now, look at that. Let's get the parent name. We start from the back. 1, 2, 3, 4, 5. Extending the parent name. On the second, we have methyl. On the third, we have methyl, and on the fifth, we have methyl. We say 2, 3, 5. Try methyl again. Yeah, if I have tried to label this thing from the front, which I'm trying to show you, look at the name you are going to see. This will be what you can see. We have 2, 4, 5 trimethyl. If I started this, you will see something now. Both of them, if I start from the front, I have 2. If I start from the back, I have 2. So, but in this case, I'm going to consider the first point of difference. 2 and 3 is close by compared to 2 and 4. That is all called point of difference rule. So, point of difference rule is also point of difference. The point of difference rule is also important when you are naming what organic compounds. So, first point of difference is also very important and it's also very key in name. So, keep that in mind. It's very, very important. Again, another person can say addition of the word lowest sum rule is also going to work. But most time, the lowest sum rule can also tie. When there is a tie, you are going to break it by what? The first point of difference. Now, the next is the cycloalkane, which is the last aspect we are going to learn in this video. The aim of this video is to understand how to name what different what alkane substance, and how do you name alkane substance. Both the cyclo and the non-alkane are what we have, and the straight alkane are what we are going to talk about. About cyclo, the point is to know that the general rule and some basic properties. The cycloalkane is just an alkane which carbon atom was in rings. So the second point is what cycloalkane are also known as what they are also known as what saturated hydrocarbon, and what they have what maximum number of bonded hydrogen as what as a single bond. So then their general formula I told you is what CnH2n, whereby they start on what the third, the fourth, and the what and so on and so on. But you don't have cyclo for the first carbon and the second carbon. So the next point is just to understand how we name them. To understand them, we talk about the nomenclature of cycloalkane, and please be very, very careful that cycloalkane with only one lingua name with the prefix cyclo to the name of the alkane. So please, very simple to name, like I said, look at the monocyclic. For example, three carbons here, we call them, just put cyclo in the front of what they name, cyclopropane. The next one, just put cyclobutane. You can say 5 chains, cyclopentane, and so on and so forth. The second point is if only one substituent is present, it is not necessary to designate its position. So the very good example to understand that is this. Look at this. Fine. We have, you can see this is just one substituent, which is chloro. So you just say chlorocyclopropane. So instead of saying one chloro, you don't need to do that. It's not necessary. So chlorocyclopropane is very simple to know, and that is that. The next one, you can say just can't. This is methyl, it's a substituent. You don't need to write the number. So it's very simple. This is what? Methylcyclohexane. How is it hexane? Just 6 carbon. You can name that, and I'm very sure about that. I know you guys can do that. So that is 6 carbon. And because it is a ring, they call it cyclohexane. So that is that about the first law about for this. The second law. The third law states that for you to understand this very well, always note that if two substituents are present, numbers of carbon of the ring beginning with the substituent according to alphabetical order. So always label alphabetically is also very important. Look at this. The numbers in the direction that give the next substituent with the lowest possible number, lowest number possible. So this is also more like what we have studied. Now look at this. Now if I want to label this, the first example, look at that. I'm starting there. That is 1. Then the next 2, you can see they are very close. Why? 1 and 2. If I have started like 1, 2, like in the other way, the 2 substituents that I have spotted here are not going to obey my lowest number, which we have talked about. So 3, 4, 5, 6, which you know, 4, 5, and 6. So now label the substituent. This is very, very simple. So this is, you can see the substituent here. You know now, and you know this one, and you know you have to label alphabetically. So ethyl should come, normal. That is the way you say it. So this is 1 ethyl. You can see I'm putting the position because there are more than one substituents. So 1 ethyl, then 2 methyl, then cyclo. It is not 1 and 6. So if you have labeled 1, 2, 3, 4, 5, 6, this is very, very long because 1 and 6 are farther apart from each other. So please keep that in mind. 1,2-methyl cyclohexane is the correct name for this word, cycloalkane. So the next is this, which is also more like the same thing we have studied. So follow the same thread when you are labeling. And if I have done that, we have something similar to what you have studied before. You can say the first one, the second, then the third one, like that. So it is on the first and the third that we favor me. And it's very simple. That is 1,3-dichlorocyclopentane. So cyclopentane is the parent in which we write first. We know we separate numbers by comma, then we write the substituent by putting hyphen. So it is 1 and 3, which is very, very important. If you have said 1, 2, 3, 4, or 1, I know you guys, 1, 2, 3, 4, 5 is very wrong. So it is not 1, 2, 3, 4, 5. So people say 1, 2, 3, 4, 5. No, or whatever you want to label. 1, 2, 3. So look for the one that's close and place when you are trying to talk about different substituents. Remember to label what alphabetically. So these are logics on all this stuff. And I don't want you guys to think these are very, very, very difficult. They are not difficult. In fact, that is why I'm taking it from basics to advanced. Now, when 3 or more substituents are present, begin the carbon atom of the substituent that leads to the lowest set of locants, lowest location. So that is what we call lowest location. Look at this. We have spotted 3, or let me just do something. You can see we have chloro, we have ethyl, and we have we have chloro, we have ethyl, and we have methyl. Now let's look at that. The law, according to the law, we are starting from 1, 2, 3, 4, 5, and 6. So you can say 1 is chloro, 3 is ethyl, and 4 is methyl. So 1 plus 3 plus 4, that is 8. Another thing you can see is that this is the best grouping I can give. If I have started from the other one, I'm going to have something that is different. And if I have something that is different, it will not give me the lowest location in terms of how they are close to it. You can see the first point of difference is even very, very close. And again, the location, that is the closest location I can get in this level. So to label, the name is what cyclohexane, we know that. Then, the first one is 1 chloro, then the second one is 3 ethyl, then the third one is 4 methyl, then you put the parent name. I hope you understand. You don't put comma here because you are not separating numbers. Whenever you are adding substituent, the number, then hyphen. Please, I beg you, don't make mistake, because the examiner nowadays also tests that in the bed. So the next point is we talk about another way to see that. You can see that is it. If you have started labeling like you start 1, 2, and 4, this is what you are going to have. Then you can have this answer also 4 chloro, 4 chloro. Why am I starting from 4 chloro? Alphabetically, I will never forget that. Don't ever forget that. It's very important. 4 chloro, 2 ethyl, then 1 methyl cyclohexane, which makes the second one to be what? Correct, and the first one to be right. Why? It is because of the what? Location. It is because of the what? Location. Now, please, location is very, very important. Now, guys, let me explain in detail for you to get why we say this is correct and this is what this is from. Now, if I started from this 4 chloro 2, 4 plus 2, 6, 6 plus 1, 7. Look at this one, 4 plus 3, 7 plus 1, 8. As 7 is less than 8, I hope you understand that. The lowest location is that. The second one is more correct than the first one. So in objective question, it's very easy to understand which is correct by looking at the location. Now, if you look at, in this case, if you look at the first point of difference, there is also the same thing. You understand? Because we always tell students two things are important when you are doing cyclo. It is what? Locant, lowest sum low, and point of difference. So I have actually tried to explain this in a way that I believe most of you actually follow my trial. I think the first one is the most correct one. But when you look at another way of rearranging, so sometimes it's always good for you to arrange starting clockwise and you try it the other way, counterclockwise. You can start from the first one and start from the other one. Then look at the lowest locant, which one was favors most. So when you spot the one that favors you most, you go for the one that has the lowest locant. I hope you understand it, and that is that about it. So guys, the next one, I'm going to talk about this one before we call it today. So it is almost time. About this one, we have spotted different what? Substituents. We know the parent's name by seeing this. And on top of 2 of them, you can see the first one is here. Then this is here. And also here. My student need to be careful about naming. Now, if I have named this as what you expect me to name, I will have had issues or difficulties. Sorry about that. Now, if I have named this as you can say 1, 2, so I say 3, 4, and 5. So if I say 1 methyl or whatever, it is very, very wrong. Now, here, the best way to have named this is 1, you can say 2, then 3. I hope you can see. Then I have 4 and what? And 5. And that will give me the lowest locant, which is what we're talking about. Lowest locant is always very good. So you can say 1 comma. This is 1 on the first one. We have what? We have the ethyl. This is ethyl substituent. Very simple to name it. Then we also have on that same one ethyl. On that same one, we also have 1. You can see methyl. Then on the third carbon, we have what? We have another methyl. So you have to be careful about this. So it is 1 ethyl, then 1 comma 3. 1, 1, 3. That is the number. If you compare the other way I've labeled before, it will give me 3, 1, 3. It goes without saying. You can say lowest location. Then in terms of difference, point of difference, 1, 1 is better than saying what? 3, 1. Do you understand? So this is first point of difference here makes this one correct, because if it's go by lowest sum, 1 plus 1 and 3 is same as, you can say 1 plus 1 plus 3. Sorry, this is 2 plus 3 is 5, and this is 7. You can see what I'm talking about. So in cyclo, we always point to what we call first point of difference, and we also talk about what we call locants, or the lowest sum. So always keep this at the back of your mind when you are labeling cyclosubstance. In this video, we only talk about alkane, labeling of the straight chain and the cyclocompounds. And I hope students have gotten 1 or 2 things to understand what you need to know. Now, the step 5, which is the final step I will talk about in this video, is talking about another law, which is also very important. When a single ring system is attached to a single chain with greater numbers of carbon atoms, then students should keep in mind that when that occurs, you have to have when more than one ring system is attached to a single ring, single chain. This is where something is. Then it is appropriate to name the compound as cycloalkane. When a single ring system is attached to a single chain with a greater number of carbon atoms, or when more than one ring system is attached to a single chain, then it is always appropriate to name the compound as cycloalkane. Please keep this in mind. I'm going to do an illustration, because without illustration, we are nothing. We won't be able to get the gram. Now, this is what we are talking about. Now, the numbers of carbon are the ring. Now we talk about the alkyl. Then the alkane is talking about the number of carbon as the linear chain. This is very simple. Look at this. I told you this is the last one, and I have reasons for taking this as the last one. So always name it as cycloalkane. The cyclo, the alkyl, then the alkane. Alkyl means the number of carbon as the ring. Then the alkane is the number of carbon as the linear chain. Please, very important. Because most times now we say, how will I name this structure? It is kind of too hard. Nothing is hard if you know the concept. That is my way. So cycloalkane, the alkyl in the word in the name is called the number of carbon as the ring, inside the ring alone. Then the alkane is the number of carbon on the straight chain. So this is a very good example which I've shown you. Now look at this. We can see the ring. So this is a bond line notation. Don't worry, I'll count it for you. Now we can see counting this, there are what? 3 carbons. There are 3 carbons, as you can see. Be very, very careful. You don't need to disturb yourself. Now, here I have 1. You have to be careful about this. 1, 2, and 3. 1, 2, and 3. These are now attached to what? This is what we are talking about. This is what? The straight chain. 3 carbon. So 3 carbon. So on the first one, I have the first substituent. Please visualize like this. On the second one, or the third one, I have what? This substituent. I hope students are getting this. Now, from what we say, the name, the parent's name, I'm just trying to give you some illustration. Now, the parent's name, the number of carbon as the ring is the alkyl, whereby the alkane is the number of carbon as the linear chain. So if you want to call cycloalkane, you always keep that at the back of your mind. Cycloalkane. So now cycloalkane. You can see on the first one I have the first substituent. On the second one I have the what? On the third one, the first one and the third one. So I have cyclohexyl propane. You can say cyclohexyl propane, and there are 2 of these. That's why we're using that. Now, cycloalkane. That is the way we name it. Cycloalkane. The parent's name will be the linear bond, which you have studied here. The linear bond is 3. That is cycloalkane. You have this propane. It's called propane because it is propane. So cyclo of the what? Of the substituent. There are 2 substituents. That is dicyclo. Then the name of the substituent of the what? Of the cyclo. You can say is the alkyl here. So here we call this one. It is what? Exhale because it's a substituent. You understand? This is not what I have show. I think I showed the class. We're talking about what? This is not cyclohexane. It is exhale because it's what? It is what? It's, you can say the last one has been what? Is not reactive. It is used as well as a substitute to join to this one. So I hope you understand this and why. If I start either from this side or from this side, I'm still going to have 1 and 3, and this is the way we label this type of situation. So you don't need to be afraid when you see something like this. Cycloalkane, that is the logic. So I always tell students to keep at the back of their mind. So the same thing is also going to be done here, as you can see. So you know, I told you, you have to just can't, just like if I were you, I always write cycloalkane. So you count the alkane family as in what? The straight chain. So you can count the straight chain together. If we count the straight chain, this is 1, 2, 3, 4, 5. So on that we have this is now counted as a substituent as usual. So substituent. So I'll call this one cyclo. You can say this is now butyl. So and it's on the first one. So write 1 cyclo butyl pentane. I hope students understand this. So this is where I'm going to stop on this video lessons. See you guys soon in my future video. Thank you for always being there. Don't forget to subscribe to my channel and don't forget to tell your friend about this channel. Bye. Thank you.